You open LinkedIn and see 3 job postings: data scientist, data analyst, and data engineer. All 3 mention Python, SQL, and working with data. The salaries overlap. The descriptions sound similar. You're confused. What's actually the difference? Which role should you pursue? And why do companies seem to use these titles interchangeably? This confusion is costing mathematics graduates real opportunities. You might be applying for data scientist roles when you're actually better suited for data engineering, or vice versa. You might be preparing for the wrong interviews, building the wrong portfolio, or developing the wrong skills. Welcome to Maths Whisper, where we cut through career confusion with clarity. I'm your host, and this is episode 4 of our career series. Today, we're definitively distinguishing between data scientist, data analyst, and data engineer, what each role actually does, what skills they require, which suits your mathematical background, and most importantly, which career path aligns with your strengths and interests. Let's start by acknowledging why this confusion exists. These roles emerged relatively recently, within the last 15 years, and they evolved organically. As companies realized they needed people to work with data, there's no universal standard. Different companies define these roles differently. A data scientist at a startup might do what a data analyst does at a tech giant. But despite the variation, clear patterns exist. And understanding these patterns helps you navigate your career strategically. Let me give you the fundamental distinction that clarifies everything else. These 3 roles exist on a spectrum. From business-focused to engineering-focused, data analysts are closest to the business. They answer specific business questions using existing data and tools. They're tactical, focused on insight generation and reporting. Data scientists sit in the middle. They build predictive models, develop new analytical approaches, and create data products. They combine business understanding with technical depth. Data engineers are closest to the engineering side. They build and maintain the data infrastructure that makes analysis and modeling possible. They're focused on pipelines, systems, and scalability. Think of it this way: data engineers build the kitchen and ensure ingredients are fresh and accessible. Data scientists create new recipes and perfect cooking techniques. Data analysts prepare meals based on existing recipes and customer preferences. Let's dive deep into each role, starting with data analyst, since it's often the entry point for mathematics graduates. Data analyst, the business translator. A data analyst's primary function is answering business questions with data. Marketing wants to know which campaigns drove the most conversions. Sales needs to understand regional performance trends. Product teams want to know how users engage with features. The data analyst provides these answers. Day-to-day work involves querying databases with SQL, creating dashboards and visualizations, conducting A/B test analysis, building reports, and presenting findings to stakeholders. You're working with established datasets, using standard analytical techniques, and focusing on descriptive and diagnostic analytics. What happened? Why did it happen? The skill emphasis is on SQL proficiency. This is your primary tool. Excel and spreadsheet expertise, visualization tools like Tableau or Power BI, basic statistics and hypothesis testing, and crucially, business acumen and communication skills. You need to understand the business context deeply enough to ask good questions and translate findings into actionable recommendations. For mathematics graduates, data analyst roles leverage your analytical thinking and statistical knowledge. The barrier to entry is relatively low. You can become job-ready in 3 to 6 months of focused skill development. Salaries typically range from $60,000 to $100,000 for entry to mid-level positions, with senior analysts reaching $120,000 plus. The career path often progresses from junior analyst to analyst to senior analyst, with potential moves into analytics manager, business intelligence roles, or transitioning into data science if you develop ML skills. The work tends to be more repetitive and less intellectually challenging than data science. You're often answering similar types of questions repeatedly, but it provides excellent business exposure and teaches you how data drives decisions in real organizations. For your mathematical background, data analyst is an accessible entry point. That doesn't require deep programming skills initially, though. Developing them helps career progression. Data scientist, the model builder. Data scientists build predictive and prescriptive models. Instead of just analyzing what happened, they predict what will happen and recommend what should happen. They create machine learning models, design experiments, develop new analytical methodologies, and often create data products that directly generate business value. The day-to-day work includes exploratory data analysis to understand patterns, feature engineering to create useful model inputs, building and training machine learning models, evaluating model performance, deploying models or working with engineers on deployment, and communicating results to both technical and non-technical audiences. The skill emphasis is on programming Python and R, machine learning algorithms and frameworks scikit-learn, TensorFlow, PyTorch, statistics and probability deeper than analysts, SQL for data extraction, experimental design and causal inference and data visualization. You also need strong problem formulation skills translating vague business needs into specific analytical problems. For mathematics graduates, this role is particularly well suited. Your background in calculus, linear algebra, probability, and statistics provides the theoretical foundation many self-taught data scientists lack. You understand why algorithms work, not just how to apply them. The path to becoming job-ready is longer than for analysts, typically 6 to 12 months of intensive skill development if starting from a pure math background. You need to learn programming, machine learning, and practical data manipulation, not just theory. Salaries are higher: $90,000, $130,000 for entry-level, $120,000, $180,000 for mid-level, and $150,000 to $150,000 plus for senior roles, especially at major tech companies. Total compensation including stock can be significantly higher. Career progression typically goes from junior data scientist to senior data scientist, with options to move into machine learning engineer roles, management leading DS teams, or specialized research positions. The work is intellectually stimulating. You're solving novel problems, applying advanced mathematics, and seeing direct impact when your models improve business outcomes. However, it can be frustrating when business stakeholders don't understand or appreciate the technical complexity involved. A crucial reality: the data scientist title is overused and often misleading. Many positions called data scientist are actually advanced analyst roles. True data science positions require building models, not just analyzing data. When evaluating opportunities, look at the actual responsibilities, not just the title. For mathematics graduates, data science is the most natural fit if you're willing to develop strong programming skills. Your mathematical maturity is a significant advantage. Data engineer: the infrastructure builder. Data engineers build and maintain the systems that make data analysis and modeling possible. They create data pipelines that extract data from various sources, transform it into usable formats, and load it into databases or data warehouses (ETL) processes. They ensure data quality, reliability, and accessibility. The day-to-day work involves writing code to automate data movement, building scalable data pipelines, optimizing database performance, ensuring data quality, and monitoring data systems, working with cloud platforms AWS, Google Cloud, Azure, and collaborating with data scientists and analysts to provide the data they need. The skill emphasis is heavily on programming Python, Java, Scala, SQL, and database design, much deeper than analysts or scientists. Distributed computing frameworks, Spark, Hadoop, cloud platforms and services, data warehousing concepts, and workflow orchestration tools Airflow, Luigi. Software engineering best practices, version control, testing, code review are crucial. This role is less about statistics and mathematics, more about computer science and engineering. For mathematics graduates, data engineering requires the most significant pivot. You need to develop substantial software engineering skills, which goes beyond the scripting level programming needed for data science. The path to job readiness is 8 to 15 months for someone from a pure math background, because you're essentially learning software engineering. However, some mathematics graduates find they love engineering. The logical thinking and problem solving translate well. Salaries are competitive with data science: $90,000, $130,000 for entry-level, $130K, $180,000 for mid-level, $160,000 to $150,000 plus for senior roles. At major tech companies, compensation can exceed $300,000 for senior positions. Career progression goes from junior data engineer to senior data engineer, with potential moves into data architect, engineering manager, or platform engineering roles. The work is less visible than data science or analytics. When pipelines work perfectly, nobody notices, but when they break, everyone complains. However, It's intellectually satisfying if you enjoy building robust systems and solving engineering challenges. For mathematics graduates, this path makes sense if you discover you enjoy programming and engineering more than statistics and modeling. Some math grads realize they prefer the clarity and determinism of engineering over the ambiguity of modeling. Comparing the 3 key dimension slits compare across several dimensions to help you decide which fits you. Technical depth, data analyst, moderate technical skills, heavy business focus, data scientist, deep technical skills and statistics, ML. Moderate engineering, data engineer, deep engineering skills, moderate statistics, program intensity, data analyst. Light SQL primarily. Some Python are data scientist. Moderate to heavy Python are for analysis and modeling, data engineer. Heavy Python, Java, Scala for production systems, mathematical intensity. Data analyst, basic statistics, data scientist, advanced statistics, probability, calculus, linear algebra, data engineer. Minimal, some algorithms and data structures, business interaction, data analyst, very high. Constant stakeholder communication, data scientist, moderate, regular, but less frequent. Data engineer, low to moderate, mostly with technical teams. Problem definition, data analyst, problems clearly defined by business. Data scientist, translate business needs into analytical problems. Data engineer, technical requirements from data team needs, impact, visibility. Data analyst, direct and immediate insights, informed decisions. Data scientist, medium-term models deployed. Value accrues over time. Data engineer, infrastructure invisible when working, critical when broken. Job market demand, all 3 are in high demand, but with different dynamics. Data analyst positions are most numerous and accessible for entry level, especially outside major tech hubs. Every company needs analysts. Competition is higher because barriers to entry are lower. Data scientist positions are highly competitive, especially at top companies. Many applicants, but companies are selective. The market is somewhat saturated at junior levels but hungry for experienced practitioners. Data engineer positions have strong demand with less competition. Fewer people pursue this path, but companies desperately need data infrastructure, especially high demand at scale-ups and established tech companies. Which role fits your mathematical background? If you love statistics, modeling, and prediction and you're willing to develop strong programming skills, data science is your path. You'll leverage your mathematical training most directly. If you prefer clear business problems, immediate impact, and heavy communication, and you want faster entry with less intensive programming, data analyst is your route. Your analytical thinking is valuable even without deep technical skills. If you discover you love programming and building systems and you're willing to pivot away from statistics toward engineering, data engineering offers a rewarding career. Your logical thinking translates well even if the math itself is less central. Hybrid paths and transitions. These roles aren't silos. Many people start as analysts, develop technical skills, and transition to data science. Others move from data science into machine learning, engineering, or data engineering, a common progression. Start as data analyst, accessible entry gives develop programming and ML skills, gives transition to data scientist, gives possibly specialize further. Or start as data analyst gives discover you love the data infrastructure challenges, gives learn engineering skills, gives transition to data engineer. Some companies have analytics engineer roles that blend data analysis and data engineering, building data transformation logic and analytics infrastructure. This hybrid role suits people who like both business context and technical implementation. Making your decision. Consider these questions. Do you enjoy programming? If yes, data science or engineering? If no, analyst. Do you want to work closely with business stakeholders? If yes, analyst. If no, engineer. Do you want to build predictive models? If yes, data scientist. If no, analyst or engineer. Do you get satisfaction from building robust systems? If yes, engineer. If no, analyst or scientist. How important is rapid career entry versus long-term earning potential? Analyst offers faster entry. Data science and engineering offer higher ceilings. Do you want to maximize use of your mathematical training? Data science is the closest fit. Engineering least directly uses it. Analytics uses it moderately. Practical next steps based on your choice. Here's your action plan. Choosing data analyst. Master SQL. Most critical skill. Learn Excel, Google Sheets. Advanced feature SPIC, a visualization tool. Tableau or Power BI. Study basic statistics. And A/B testing. Build a portfolio with business focus projects. Practice explaining technical Finding simply using data scientist, learn Python deeply pandas. Scikit-learn study machine learning systematically master statistics. And probability-compiled Kaggle competitions build end-to-end ML projects understand model deployment. Basics using data engineer, learn Python or Scala for data engineering master. Scala database design study distributed systems Spark, learn cloud platforms AWS, GCP, Azure. Build data pipeline projects understand software engineering practices overlap. All three roles need SQL, data manipulation skills, and basic programming. Start with these common foundations, then specialize. All three benefit from domain knowledge, communication skills, and business understanding. These soft skills often matter as much as technical abilities. The title trap: don't get too attached to titles. Focus on the work you'll actually do. A data scientist role at Company A might be less technical and interesting than a senior data analyst role at Company B. When evaluating opportunities, ask, what does the day-to-day work involve? What tools and technologies will I use? What types of problems will I solve? Who will I work with and report to? What's the career progression? The answers matter more than the title, your mathematics advantage. Regardless of which path you choose, your mathematical background provides advantages for data analysis. You understand statistics more deeply than self-taught analysts, making you more reliable and able to handle complex analyses. For data science, you have the theoretical foundation to understand algorithms, not just apply them, making you a stronger practitioner. For data engineering, your logical thinking and problem-solving translate to engineering, even if the math itself is less central. The market reality in 2026, the data field is maturing, entry-level positions are competitive, junior roles increasingly expect some experience, creating a frustrating catch-22 strategy. Consider internships, freelance projects, or starting with data analyst roles to gain experience, then transition. Don't wait for the perfect data scientist position if you can get practical experience as an analyst. The field also increasingly values generalists who can do multiple things reasonably well over narrow specialists, especially outside major tech companies. Being able to analyze data, build models, and communicate effectively makes you very employable. Final recommendations for most mathematics graduates with no prior programming experience: start with data analyst roles while developing data science skills. This provides income and experience while you learn. For mathematics graduates with some programming background, pursue data science directly. If you're passionate about modeling and willing to develop engineering skills, for mathematics graduates who discover they love programming, consider data engineering. If you're drawn to building systems more than statistical modeling, the beauty of this field, you're not locked in. Skills transfer between roles. The boundary between data science and analytics is porous. People move between these careers regularly. Your mathematics degree is your foundation. These three career paths are different ways to build on that foundation. Choose based on your interests, not just salary or prestige. If you're a mathematics graduate navigating your career path in data, subscribe to Maths Whisper. We're creating practical content connecting mathematical training to successful careers in the data field. Tomorrow, we're exploring the actual interview process for data roles, what companies really ask, how to prepare, and how to showcase your mathematical thinking in interviews. Hit subscribe, ring that bell, and comment which role appeals to you most: analyst, scientist, or engineer. Let's navigate the data career landscape together, one informed decision at a time.